Should say that again?
So this should be the last one for Allison.
Okay, hopefully for her, yeah. Okay. Well, get your calculator out and put it in degree mode. Now we realize that we're not looking for the sine of an angle. We're looking for the angle whose sine is negative 8/10. If you're coming to Extra Help today, sign up. We're looking for the angle whose sine is 9/10. So go to second function, sine, second function. Now type in negative 0.8. And to the nearest degree, what do you get? Okay. Colin.
Negative 53.1.
To the nearest degree,
Negative 53.
negative 53. Okay, so when we get that, what we are really doing is this. We are asking for the inverse. We're asking for the angle whose sine is. Now this gets me into the heart of today's lesson. And you said it's what, 50 what?
3.
3. Okay. And he said it's what kind of a 53?
Negative.
Ah. Now, so you say, but we are that's not in, we're looking for angles between 0 and 360 degrees. So we want, usually when we solve an equation, they ask us to go through one whole revolution. Now we know that those functions are periodic. So we know that we could get an angle and every one of the billion angles coterminal with it. So this brings us to the concept of inverse trig functions. Now you better take really good notes here. The inverse of the trig functions. We know from an earlier chapter that only one-to-one functions have inverses. So a whole parabola doesn't have an inverse. Because when you lie it on its side, it's not, now don't write this down because you should know it. Okay, a parabola is a nice function, but it doesn't have an inverse because when you lie it on its side, it's not even a function. It fails. The vertical line test is not even a function. And the inverse of a function has to be of the same animal. The inverse of a real number's got to be a real number. The inverse of a function has to be a function. And this blue thing lying on its side fails the vertical line test. It's not even a function. So what do? We mechanically clamp down on the domain and we say, then just take half of the parabola, okay? And find its inverse. Oh, okay. Now, here's the thing. Not a single one of the trig functions is one-to-one. Look, if they all fail the horizontal line test, they're many-to-one. There are many, 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 many angles that have, say, a sine of 1 or a sine of like 9/10. There are many, many angles that have a sine of negative 1/2. So we have got to make an agreement and then remember the agreement that this angle right here that we got is gotten from we take the branch of the sine function. Oops. And I want you to write this down with me once we get it. Okay, now we take the part of, now look at the sine function. At negative 90 degrees, tell me, where is it up there? Look at the picture. Negative 90 degrees, where is it? Is it up at 10? Is it up at 1? Is it down at 5? Is it down at 1? What is it? And, Anna?
-1.
It's -1. So, right there. Now, at 0, the sign of 0 is 0, and at 90 degrees, it's up there. Now, we have got to remember that it's not like a straight line segment. It's like kind of like a parabola opening up and a parabola opening down. Here, this branch of the sine function, we will always find our inverse on it because it's 1 to 1. This is the inverse of the sine function. You get the idea? So now, when we ask the calculator for an angle whose sine is -8/10, it will always deliver the principal angle. So I will write up here, and you could write it too. It will always deliver the principal angle. The principal angle, meaning the angle on the principal branch. You know, on the smallest period near the origin that covers the whole range. Because look, the range of the sine function is y is less than or equal to 1. So if you stick to that branch, no matter what you give it, as long as you don't give it like, don't say, oh, the sine of x equals like -0.8. No, let's make it, I'll make it really outlandish. It equals like, say, 5.3. Well, you try this. And you're going to get an error message because there is no angle that goes up as high as, that has a sign that goes up that high. You're going to get, it doesn't exist, an error message, which means that you're asking me to give you something that doesn't exist. Does not exist, you would say. You understand? So, therefore, so now we know why the calculator's giving us, that -53-degree angle. Well, this is what we do. We'll use it. We will certainly use it. -53 degrees. Let's draw. Now, on the graph, y equals the sine of x, now bring that back to the quadrants. All right, a positive 90-degree angle is up there. A negative 90-degree angle is down there. So the principal angle will always be in one of these two quadrants. Always, always, always. Because it always comes from that branch. And that branch, back to your quadrants, really goes from a negative 90 to a positive 90. So, all right, so now we're going to say, okay, we will look at that -53-degree angle. It's not an answer, but it sure will help us. Well, just go around the positive way. Don't go in the back door, go in the front door. So, what angle? So now going back to this problem, x could be what angle to the nearest degree? Yes. 307. How did you get that? Yes, just took 53 from 360. But now you've got to have your smarts about you. You have to say, well, the sign is a negative number, not just on the principal branch, but the sign is -0.8 also in the third quadrant because you're going to the left and you're going down. So 53 will serve us as the reference angle. So what other angle? Yes, Anna?
233.
233. How did you get that?
180 plus 50.
Just as 53 more than 180. Now look up here. That answers this question. Are they the only angles that have a sign of negative 8/10? No. They're the only ones in one sweep of the quadrants. Because look, all right, negative 8/10. Negative 8/10 would be about there. You got it? But watch. Oh, there's another angle between a straight angle and 270 degrees, which has a sign of negative 8/10. Do you get the idea? All right, so you're constantly going between this picture. You draw the smallest branch that will cover the whole range. The smallest branch that will cover the whole range. And translate it into quadrants. Oh, it's either going to be up to positive 90 or down to negative 90, period. You got it? Then answer your question. All right, now here's another one. Solve this, but remember for x, in between 0 and 360. All right, it's not special because look up here. You know, you should have these, the tangent is special only when you see a 1 or these, okay, it's not special. So go to the calculator, hit second function tangent, and it looks like this, second function tangent, and you're putting it -2. To the nearest degree, what have you? Samantha?
-63 degrees.
-63 degrees. Okay, now, what is the principal branch of the tangent? Okay, well, let's look at the tangent graph. Now, this is the tangent graph right here. And I am holding you responsible for at least the first branch of it. All right, so now, you have to know that, well, at 90, you've got your first asymptote. So let's say 90. And at -90, you have another asymptote. Now, you've got to know, you've got to know some things. The tangent of 0 is 0. And it looks like this, kind of like a parabola opening up and a parabola opening down. You are expected to have that in your mind. That's what it looks like. So now, this is -90, and that's +90. But on the poster, it goes by -π/2 and +π/2. So the calculator gave you -6. Okay, now translating into the quadrants, -90 is down there, +90 is up there. So the principal angle for the tangent will always be either a positive acute angle or a negative acute angle. They gave you one down here. Do you see? They'll always give you one on that branch between -π/2 and +π/2. So now you understand what that is. Okay, so you say, all right, that's not my answer, but it will certainly help me get it. -63 degrees is there. Well, fine. Go around the positive way. So x would be, yes,
297.
297. If there's any error, you're going to let me know. And you'll notice that this is 270. 297 dipped into the fourth quadrant. Great. But the tangent is negative whenever the sine and cosine have different, like cosine's positive, sine's negative. Tangent's negative there. In what other quadrant are the sine and cosine of different signs? Yes, the second quadrant, because the cosine now is negative and the sine is positive. So 63, do you see your vertical angles there? 63 is a reference angle. So give me a positive angle that is coterminal with it. Allie?
243.
243. How did you get that?
180 plus 63.
180 plus? Well, that would put me into the third quadrant. If I go more than 180, I don't want to go to the third quadrant. So correct that. Do I want to go? Am I down here? No, I'm not down there. So you went too darn far. So tell me.
17.
Can't hear you.
17.
17. Where the heck is that?
117. I meant.
Pardon?
I meant 117.
Oh, 117. Do we agree there? Okay. Now you check yourself. Are these numbers positive? Check. Are they between 0 and 360? Check. I'm done. There are infinitely many more angles coterminal with them. But we know how to get them. Once we have these two, we know how to get the others. All right? Third, cosine of x is negative 8/10. Well, again, that's not a special angle. No special angle has a cosine of negative 8/10. So, go to your calculator, second function cosine. And you're looking now for the angle which has a cosine of negative 8/10. To the nearest whole number, what do you get, Logan?
143.
Say that?
143.
143. Do you agree? Now this is strange. Last time the principal angles were negative acute angles. But it's giving us a positive. And it's not even acute. What's going on? Well, let's look at the cosine graph. All right? Look at it. Up here. The cosine, from negative 90 to 90 doesn't cover the whole range. But if we went from 0 to a straight angle, it would cover the whole range. You got it? So we choose, here it's the cosine function is not 1-to-1 there. But if I'm between 0 and 180, it's 1-to-1. So now I got to remember this. Here's 0. Oops. Okay. What's the matter? What's going on?
Oh, nothing.
Where you go? Nothing. Okay. 0, 90, 180. That's the part of the cosine graph that you need to memorize. And easily, the cosine of 0 is 1. The cosine of 90 is 0. And the cosine of 180 is negative 1. But the graph is not a straight line segment. It goes like this, like a parabola opening down and a parabola opening up. So, this angle, 143 degrees, is about there. Do you see? It's between 90 degrees and a straight angle. Now, flip back to the quadrants. It's not in the first quadrant, but it is in the second quadrant. So the principal angle for the cosine will always be between 0 and pi. Between 0 and pi. And the one that they just gave us was 143. That's where that angle lives in standard position. This is where that angle lives on the graph. They're two different things, but they're saying the same thing. Do you get the idea? So you might say, no, that's down here in the fourth quadrant. We're not talking, we're just looking at the graph. The graph. But in quadrants, that angle's not in standard position. Put it in standard position, and by gum, it is in the second quadrant. You got it? So, now we say, all right, we've got an answer that we can work with. And lucky for us, it's an acceptable answer. It's positive. Okay, and I include 0, but I don't include 360 because 360 is, we're coterminal with 0. So, you get it? So now, where else is the cosine negative? I got to know this. Where else is the cosine negative? In what other quadrant, Colin? Third. So, now, this is 143. You better find that guy's reference angle and then put it down there. So, what is 143's reference angle? Justin Chassis?
37 degrees.
Right. Now, you want to go 37 more than a straight angle. And what do you get, Justin?
217.
217. So our answers are 143 and 217. And that's it. You got it? Okay. So that's the whole idea. When you are, so the principal angle for the cosine, let me write it this way. The principal angle for the cosine will always be between 0 and 180 degrees. It will always be either a first or second quadrant angle. Yes?
Would it be 37 and 217? Or
What the heck?
instead of 143 and 217? Or was I missing?
Say that again?
So wouldn't the angles be 37 and 217, not 143 and 217?
Well, you said, wouldn't it be 37? Now you're going to tell me why no, it won't be 37. Because if it were 37, the cosine wouldn't be negative. Do you see? And if the cosine were positive 8, then I would have gotten this directly. Okay? So that was a good question. So the principal angle for the cosine will always be on this branch, but translated into quadrants, first between 0 and pi, first or second quadrant. Now let's go back to this guy. The principal angle for the tangent will always be on this branch right here. All right? But, so let me say it this way. The principal angle for the tangent will always be between negative 90 and 90 in standard form, it would be either a fourth quadrant negative acute angle or a first quadrant positive acute angle. We'll say it this way. The angle itself will be between 0 and 360 or 2 pi, whichever way you want to say it. All right? And the sine function, all right, let's state it. Put it down. All right? The inverse of the sine, that will always be on this branch, which puts it between negative 90 and positive 90, inclusive. Now, and in standard position, it will put us in either the first quadrant, an acute angle in the first quadrant, or an acute angle, negative acute angle in the fourth quadrant. Okay? That's it in a nutshell. You just got to drill it. Okay, so here, look. Go to page. Okay, oh, and here. This is where it is in a nutshell. So if I were you over the weekend, I would put it all like on maybe, one little place in your copybook and box it. You got it, but it's all over the place. Page 289, number 6. Now, without using a calculator, we're down here at the written, find the value of each expression in radians. Many answers can be given in terms of pi. So they're giving you a big fat hint. They're probably special angles. All right. Now, I don't want the sine of 0. I want what angle? What is the one angle on the principal branch that has a sine of 0? So I hope that right now you're going to take the time to very quickly do this. And if you do that enough times, you're going to have it memorized. Negative 90, positive 90. Negative 1, 0, 1. Aha! What is the one and only one angle on that principal branch that has a sine of 0? Justin Chen. 0 degrees. Or 0 radians. Now, what is the one and only one angle on the principal branch that has a sine of negative 1? Giovanna.
Negative 90? Or
No. Answer the question. It's got to be on that branch. You said negative 90. Does that picture say that the sine of a negative 90 degrees is negative 1? Yes. So your answer is negative pi over 2. You should go in, automatically bounce back and forth between negative 90 and negative pi over 2. That should be like your middle name. All right. Now, cosine. Well, I want the principal angle, and there's only one answer to this. We're not solving an equation. I'm just asking you for the principal angle who has a cosine of 1. Well, let's draw the cosine function. And we're going to remember that if we go from negative 90 to 90, that's not going to serve us well. It's going to give us a duplicate of the positive numbers. So let's go to, all right, here's 90, here's 0, here's 90, and here is 180. Starts up here at 1, cosine of 90 is 0, and the cosine of 180 is, and that covers the whole range. So we will find our principal angle whose cosine is 1 on that branch. What one angle on that branch has a cosine of 1? Brian Issel. Look at that branch. You find an angle that has a cosine of 1. Can't hear you.
Is it 0?
0. Don't be timid. 0 degrees, 0 radians. Right here. This point means the cosine of 0 over here is 1. All right? Now, what angle on that branch has a cosine of -1? Brian? 180. You got it? So you've got to memorize. That's why you have to know. There are a lot of other reasons where you have to know the graphs. But as far as what we're doing right now, you have to know at least that much of the graph. So you better memorize it. Okay? All right. How about this one? Now, I want the principal angle whose sine is root 2 over 2. So immediately you're thinking special, special, special angle. Well, let's draw the principal branch of the sine. And we're going to go from -90 to +90. 1 down to -1. Well, the sine of a -90 is a -1. Then 0, then a +1. And then just remember the curve. There is your answer has to be on that branch. What special angle is on that branch? And where on the branch is it? What special angle has a sine of root 2 over 2? Ariana?
45.
45. Now, look up here. Is a 45-degree angle on that branch? There it is. There it is. Okay, so your answer is going to be pi over what? What's 90? Pi over 2. What's 45?
4.
Yeah, I mean, isn't 45 a half of 90? All right. Now, I need the principal angle whose sine is negative root 2 over 2. So you're still thinking 45, but the sine of okay, so what angle? Yes.
Negative pi over 4.
-pi over 4. Here, he says, here I am. I live right there. I'm on that branch. Now, how do I read that? Well, I go up here. What angle? -45. Now, what about this guy? Well, it wants a particular angle. Well, let's go to the principal branch of the cosine. And remember, the cosine, 0, 90, 180. Starts up here, goes to 0, and we find it down here. It covers its whole range from 1 to -1. So the answer has to be on that curve. So what angle, what special angle are you thinking of? Yes, 45. Pi over what?
4.
Good. And he says, look, here I am. I'm right there. All right. What's the principal angle whose cosine is negative root 2 over 2? Well, you're still thinking of a 45-degree angle, but it's got to be on that branch. Well, it can't be up here. It's going to have to be between 90 and 180. So if it helps, draw it in standard position. It's going to have to be an angle between 90 and 180, between 90 and 180, but 45, yes, will be its reference angle, yes. But that's not the answer. Give me the measure of that angle. It's more than 90 and it's less than 180. What's the measure of it? Yes.
135.
135. All right. And there it is, 135 right there. Now, watch, look at this. 90 is, okay, pi over 4 is this. Another 45-degree angle is that. Add those two together and you get pi over 2. And here's another pi over 4. So to get that answer in radians, just say 1 to the third multiple of pi over 4. And be done with it. Yes?
And is it negative? Or,
Well, you answer that question. This angle here, 100 and, you said 100 and, what was it, 35? It's to the right of the origin, so I don't think it's a negative angle. I think it's a positive angle. All right? Now, next page. Next. Maybe it's, next page. A. Now, this, how do we read this? I want the sine of an angle. I want the sine of an angle. So I will start to pull this apart. I am looking for the sine of an angle. What do I know about that angle? I know that it is the principal angle whose cosine is 1/5. That's what that angle is, theta. All right? I'm looking for the sine of an angle. What do I know about that angle? It is the principal angle whose cosine is 1/5. That's not special, but I really don't need the calculator to get it, because look at this. If the cosine, if it's a principal angle, now keep in mind the principal angle for the cosine is between 0 and 180. So I know that the angle that I'm looking for, if the cosine is positive 1/5, then I put a 0 here, but the 0 belongs down here. It's the angle. That's a 1, and this is a negative 1. Well, if the cosine is a positive 1/5, then it's up here somewhere. It's up there somewhere. So it is a positive acute angle, but it's not special. I could ask the calculator for it, but you could really be good and say, well, I know that theta is a first quadrant angle. Do you see that? Now, how do I know that? The cosine, the principal angle has to be on this branch. The principal angles whose cosines are positive is up here. The principal angle whose cosines are negative is down there. Well, it's up here. So now if I go back to standard position, I know that it is a positive acute angle. Oh, and now I'm back to old stuff. The cosine is 1/5. Oh, the cosine 1/5 is x over r. So the x part is 1, the r part is 5. Use the old Pythagorean, find out what the y part is. Y squared plus 1 squared equals 25. Y squared equals 24. Y is equal to the square root of 24, plus or minus. That would be, reduce that radical, and I get plus or minus 2 times 6, 4 times 6, plus or minus 2, radical 6. So now, I want the sine of that angle. Well, there's theta, and I'm going to use the y positive, because I know I'm looking at my given information and I'm reasoning from it, and this tells me that it's got to be a positive acute angle, a number between 0 and 90. So it's going to be y 2 root 6 over r, 5. Do you follow? So if I give you this like in Monday's, Tuesday's test, just don't go, you can't, well, guess what? Your calculator's going to be on the floor. So you can't go calculator, crazy. So you got to go, I must be asking you something that you can do without a calculator. Did we do this without a calculator? So I'm testing you on what you know, not what your calculator knows. All right, let's look at B. Now, I'm looking for the sine of the principal angle whose cosine is negative 1/5. Oh, it's a mouthful. I'm looking for the sine of an angle. What do I know about that angle? That angle is the angle on the principal branch of the cosine function where the cosines are negative. Well, let's just look at the cosine. I think we just did it up here. I'll do it again because I did a lot of scribbling on that. Now, 0, 90, 180. All right, from 1 down to negative 1. 1 down to 0, and then down to negative 1. Now, now I look at the principal branch. It's not an angle up here because angles from 0 to 90 have positive cosines. It's got to be an angle between 190 and 180. So, it's got to be an angle between 90 and 180. So I'm going to go to standard position. That's why we have this. We bounce back and forth between two worlds. It's got to be between 90 and 180. Oh, it's got to be in the second quadrant. Now, if the cosine of that angle is negative 1/5. See, I don't even know the number of degrees in it, but I know that the cosine is negative 1/5. Well, that is x over r. So definitely the r is 5. The x must take the negative. And I don't usually write the negative down here because we're, in geometry. But that x coordinate is negative. All right, 1, use the old Pythag. Find out what y is, because the sine of that angle is y over r. Okay, so what do we have? Y squared equals 25 minus 1. Y squared equals 24. Oh, y is equal to plus or minus 2 square roots of 6. Same thing we had before. All right, but this time, well, I'm going to take the positive because I know that I am in the second quadrant and I go up. So the answer here, the answer to this whole problem is, all right, the y coordinate over the hypotenuse. Okay? Now, number 14. Oh, let's see. Number 14. I'm looking for the cosine of the principal angle whose tangent is negative 2/10. Well, take it one step at a time. I am looking for the cosine of an angle. What do I know about the angle? That angle is the principal angle whose tangent is negative 2/10. That means that I'm being told that the tangent of that angle is negative 2/10. Right? Well, let's see here. The tangent, the principal angle for the tangent's got to be between negative 90 and positive 90. So if the tangent's going to be negative 2/10, it's got to be on that part of that branch. Translate that into quadrants. Well, I'm between 0 and negative 90. Well, here's 0, here's negative 90. It's down here. So I have tangent, this is negative 2/10, which is negative 1/5. Work with the trigonometry of it, of the geometry of it, the Pythagorean theorem. Okay? Okay. Okay, there will be extra help today, and we'll be happy